If you've realized in physics so far, we've done a lot of drawing diagrams. During electricity, we did circuit diagrams. During motion, we've drawn motion diagrams. And now during forces, we're going to be drawing force diagrams. So the first step is you're going to be drawing the forces on a flamingo standing on the ground. So the first step you've got to do is draw a picture. Now on your sheet, on the left-hand side, you're going to write, draw a picture. And then on the right-hand side, you're going to do the best you can at drawing a flamingo. One of the things you want to make sure that you have is that it is in contact with the ground. So go ahead and put the ground in if you haven't already done that. 2 is to identify the receiver. Now, when you identify the receiver, you want to pick the most obvious example. So for example, the bird. Don't pick a wing, don't pick a feather, don't pick with one toe. You're going to pick the entire bird to be your receiver. After you've identified the receiver, we move on to step number 3. And step number 3 is you draw a circle around the receiver. Now, on your note sheet, write the step 3, draw a circle around the receiver. But then also what you want to do is you want to make sure that you draw your circle around the receiver and only the receiver. Do not draw the circle around the ground, and that will come up a little bit later. Now once you've drawn a circle around your receiver, and do that on your note page as well, then we move on to step 4. Step 4 is where we're going to identify all places where something touches the receiver or touches the circle. So if you take a look, let me grab my tools here. If you take a look at the points where something is actually touching the receiver, down here at the bottom, it's touching the receiver. Nothing else is touching the receiver as you go around. Okay, so it's only touching the receiver in one place, right there. Now, that leads us to picking out forces, and because something is touching our receiver, we know that's going to be a contact force. So we're going to be drawing arrows for and label all contact forces. Now if you take a look right here, I'm referring to contact forces only because something was touching our receiver. So as you can see, we've drawn in an upward force, called it a force normal, because without the ground, the bird would be in free fall. It would fall down. And in this case, the floor is supporting the bird. Now if we look on our note sheet, there are no other contact forces that we could pick out. The only one is going to be normal force in this case. And once we're finished with the contact forces, we move on to the field forces. So if you take a look at a picture, our field force, there's only one. It's force gravity, and it goes downward. Now steps 1, 2, 3, 4, 5, and 6 seem pretty similar to what we've been doing in class. This last step is what makes it a force diagram. Step number 7 is you're going to shrink the receiver to the dot. So if you'll notice, my big bird here has been shrunk to this little bitty dot, and I could even put R for receiver here if I wanted to. Now if you'll notice, I have force normal that goes up, force gravity that goes down, but it's the way you draw it that makes it a force diagram. So for example, force normal starts at the dot and goes up. Force gravity starts at the dot and moves downward. It's very important to make sure that you start at the dot and go either up or down. Otherwise, it's not a force diagram. So for example, if I drew my force diagram and I drew an upward arrow and I called it force normal, and I drew a downward arrow and called it force gravity, it would be the same forces, it would be the correct direction, but it would not be the correct force diagram. The reason it's not the correct force diagram is because the arrow has to start at the dot and move up, start at the dot and move down, and that would not be accurate. Now the other thing that we know from broomball is that my normal force is going to be the same size as force gravity. They're balanced in this case because there is no acceleration downward and no acceleration upward, so they'll be the same size. You represent that with the same size arrow. So just as a recap, the 7 steps that you need is first you start with a picture. Now, if the picture has been done for you, you don't need to draw a picture, but if it hasn't, then you do. Second step, identify your receiver. A force diagram will be different if I were to select a different receiver. Draw one circle around the receiver and only the receiver. Identify all places where something touches the receiver, and this will bring us to contact forces. We always do the contact forces first. Then we move on to the field forces. Last, you shrink your receiver to a dot, and then there you have your force diagram.